This is the law of cosines, and the law of cosines is pretty simple once you use it. It can be used to find the side lengths or angles of triangles that are not right triangles. It works for right triangles as well, but it can be used to find sides and angles given certain information of any triangle. So it's really just one basic law. And if I just cover up below this one, there's the basic law that if A, B, and C are sides of a triangle, and it's triangle ABC with angles A, B, and C, that one side length squared is equal to the sum of the other two sides squared minus 2 times each of those side lengths as a product times the cosine of the angle that's opposite the side you're trying to find. And that works no matter which side it is. If you're trying to find the side for B, you use the A and C here and the cosine of angle B. And if you're trying to find C, you use the other two sides, the A and the B here, and you're using the cosine of the angle opposite side C. So that is one form of a law of cosines, and it's with the side isolated, side squared of the triangle. And if you want to rearrange this, these can be rearranged to isolate the cosine of the angle. So if you were trying to find an angle and you knew side lengths, you could use one of these forms. This one here is just the top one rearranged and solved for cosine of A, and so on. This is the second one, and this is the third one, just in a different form to find angle. Although you don't need to use it like that, you can always just use the basic form up here and plug in everything you need to know, and find what's missing. So I think that this deserves a little proof or an explanation, because it's not good to just in mathematics take formulas for granted and not know where they came from. So what we do is we start with a little triangle that is not a right triangle, triangle ABC, and we know that opposite side angle C would be side lowercase c, and opposite angle A would be side lowercase a, and opposite angle B, I'm going to put it way down here, would be side B. So side B is this entire, in this case, longest side of this triangle that's not a right triangle. So before we do this, before we learn law of cosines, we know enough right triangle trigonometry to be able to find missing sides of right triangles. So this is a really elegant little proof because it just uses Pythagorean theorem. What I do is I just choose one of the angles and I drop an altitude to the opposite side, creating two back-to-back right triangles. And we'll just, for now, label that H for height of that triangle. And then I want to be able to look at this right triangle and this one, but I need something to call this third side here and the third side down here. And I know the whole thing is equal to a length of B. So if I call this little guy x, then this other piece would be the whole minus the part, B minus x. So then I just start with Pythagorean theorem. And I'll put a couple things here out to the side. First of all, when I look at this right triangle on the left, using Pythagorean theorem, x squared plus h squared equals c squared. So I could say that c squared, the hypotenuse squared, is equal to the sum of the squares of those two legs. That's one thing to note, and we'll save that for later. Then the second thing is that I want to note, and we'll save for later, is if I look at angle A, the cosine of angle A would be adjacent over hypotenuse, or x over c. So if the cosine of angle A is x over c, and I want to solve that equation for x, I would multiply both sides by c. So times c, and that would get me that x is equal to c times the cosine of angle A. Now I'm focusing on angle A because I'm going to find the equation for finding the side opposite angle A, which is side A. So we created this. It's really just a triangle ABC right here. So If I now focus on this triangle on the right, again using Pythagorean theorem on that little right triangle, I can say that this side squared, so b minus x squared, plus the height squared, that side squared, will be equal to a squared. So, which is the hypotenuse squared. So if I FOIL this out, b minus x times b minus x, I will get b squared minus 2 times b times x plus x squared. And then I'm still adding the h squared, and this is all equal to a squared. So now I've got some neat substitution I can do. Because if you look at this x squared plus h squared, that shows up right here. So we know that that is equivalent to c squared. So I can replace that expression with a c squared. Also, if I look at x right here, this x, we've just said, is equivalent to c times the cosine of a. So I'm going to replace that with c times the cosine of angle A. So I've still got the b squared minus the 2b times c times the cosine of a plus c squared equals a squared. And you've just derived the law of cosine, so we'll just rearrange it. We'll put the a squared in front equals, and we'll put the b squared and the positive c squared together, minus the 2bc times the cosine of angle A. So as you can see, that is the first, that's this one right here that we looked at. And you could do that over and over again for any of the sides using any of the angles. So that's a nice, that's where it comes from. So if we were to now dissolve away this height line H, and all I had was triangle ABC with sides A, B, and C, I could find the length of side A. If I knew the length of side C and the length of side B, and the angle measure of angle A. So this is pretty much a plug and play kind of thing. You have to know two sides and the angle between them, and you can find an opposite side. So let's look at some examples. The first example is somewhere in my pile. Let's see. Well, I don't know what I did with it. Ah, here it is. Okay, example 1. In triangle ABC, B is 10, C is 14, and angle A is 54. So I'm going to label a triangle ABC where C is longer than B. So let's see, if I make this B and this, I'll put C up here and A down here. I'm supposed to find side A, so that would be side little a right here. B is 10, side B is right here, so this is 10, and side C, opposite angle C, is 14. And then angle A measures 54 degrees. So I know two sides and the angle between them, so I can use the law of cosines to find the side opposite that angle. So I'm going to frame the basic law, so I've got A squared, I'm trying to find A, is the sum of the squares of B squared plus C squared minus 2 times B times C times the cosine of angle A. So plugging in, I'll have A squared, the unknown, is equal to 10 squared plus 14 squared minus 2 times 10 times 14 times the cosine of 54 degrees. So, continuing to simplify, 100 plus 140, plus 196, so this is 296 minus 280 times the cosine of 54 degrees. And I punch that into my calculator, and I'm going to leave that in my calculator. So I'm just going to punch it in directly. 296 minus 280 times the cosine of 54 degrees, and I get 100, oops, I get 131.420. So I'm just going to write this out 4 places to the right of the decimal point, because I'm leaving it in my calculator unrounded, and then I'm going to take the square root of that. So I know taking the square root is the same as raising something to the 1/2 power. So I'll just do that, and I get 11.46. So to 3 significant digits, this would round to 11.5 units. So side A is 11.5 units long. Okay, now the second example is where I've got 3 towns here, and I've got Middleton, Timbuktu, and Deerfield. And it tells me that Middleton is 8 kilometers east of Timbuktu. So I'll put a T for Timbuktu, and Middleton is 8 kilometers east, due east. So this would be moving due east if I'm looking at a map. And Deerfield is 10 kilometers northwest of Timbuktu. So Deerfield, I go northwest. So if I go exactly northwest, I take a 45-degree angle up to Deerfield, so that's D. So this was 10 kilometers. And then the question says, how far is it from Deerfield to Middleton, between those two? So we'll just call that C. We don't know. But we need to know this angle, and so we have to understand that if you had a 90-degree angle, it would look like so, going due north, and if you're going due west, it would go like this. So northwest is a 45-degree angle. So it would make this 90 plus 45, or 135-degree angle. So now I'm going to say that that unknown side is going to be equal to the 2 sides I know, 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of the angle opposite side C, which is 135 degrees. So this is going to be 64 plus 100, or 164, minus 160 times the cosine of 135 degrees. So C squared equals, I'll punch that in, 164 minus 160 times cosine of 135, close paren, 277.1371. But I leave it in my calculator to just take the square root of it unrounded, because I don't want to round to the end on the final answer, because otherwise I get rounding error. So I'll raise that to the 1/2 power, which is taking the square root, and I get 16, and to 3 significant digits, this is going to be 16.6. So 16 and 6/10. So the towns are 16 and 6/10 kilometers apart, Middleton and Deerfield. So that's it. Law of cosines, got to memorize one basic form, just what it is, understand it visually, and can use it a lot. Thank you.